In this lecture, I'm going to cover BubbleSort. That's another linear sort. BubbleSort. A bubble sorts the array in multiple phases. Each pass successively swaps the neighboring element if the elements are not in order. The BubbleSort algorithm makes several passes through the array. On each pass, successive neighboring pairs are compared. If a pair is in decreasing order, its values are swapped. Otherwise, the value remains unchanged. The technique is called BubbleSort or sinking sort, because the smaller value gradually bubble their way to the top, and the larger values sink to the bottom. After the first pass, the last element becomes the largest in the array. We call it sink down, and that we call it the heaviest element. After the second pass, the second to last element becomes the second largest in the array. The process is continued until all elements are sorted. Here is a diagram to show how BubbleSort works. So, let's get started. We get started from the first pair. We compare 2 and 9, and then 9 is bigger, so we continue to compare 9 and 5. And 9 is bigger, so we swap. And then we compare 9 and 4. 9 is bigger, so we swap. And then we compare 9 and 8. 9 is bigger, so we swap. And then we compare 9 and 1. Then 9 is bigger, so we swap. So we finish the first pass. The second pass, we started from here. We compare 5 and 4. 5 is bigger, so we swap. And then we compare 5 and 8. We remain the same. And then we compare 8 and 1. We swap. And right here we stop, because 9 is considered already sorted. It is the most heavy item in the array, so it's remain there. So after this, 8 it becomes the second largest number. So the next part we started from here. We compare 5 and 1. We swap. And 5 is the third largest number. After that, we continue the next phase. We compare 4 and 1, and then we swap. And after that, everything is finished. So, by doing this, actually the BubbleSort time is the order of n squared. The first pass, we need to finish n-1 compare. The second part, we started from here. We need to take n-2 compare, and then n-3, and then 2, and at the end with 1 compare. So we sum up this, get this formula. So that is the order of n squared algorithm. Now, let's get started from idea to solution. First, the outer loop, we have k equals 1 and the k less than this length. So k's largest number is this dot length minus 1. What does this k mean? This k means the size of the sorted array. So when k equals 1 means the first pass, we will keep one element as the largest one. Second pass, we have k equals 2, so we will keep 2 elements. And why this happen? If you look at the inner loop, the starting point k equals 1, so we started to sort from I equals 0 to list dot length minus 1. That means the last will not be sorted. Once we finish I equals list dot length minus 2, then we stop. So let's look at the inner loop. We started with I equals 0, then we compare this 0 with this 1. So we get started from the array. Say initially we get started to compare this pair. Then if the lowest index 1 is bigger than the higher index 1, then we swap. We continue to swap until I equals list dot length minus 2. Say in the previous example, the length is 6, so we end up with the index of 4. This is 0, 1, 2, 3, 4. We up to here. And the last one is comparing list of 4 with list of 5. That's the last pair. So we swap if the fourth one is bigger than the fifth one. Then we swap. So that finished the last comparison for the first phase. Similarly, the second phase, we have k equal 2. This is list.length minus 2. So the last comparison is on I equals list.length minus 3 with the list.length minus 2. So we started from I equals 0. We do the comparison. So the second pass, we started from here until list.length minus 3 with the list.length minus 2. That's the last comparison and swap. We started here, so we get the second heaviest number over here, or the second largest number over here. We continue that until the whole array is sorted out. Now, let's look at the improved BubbleSort algorithm. The basic idea for this improved BubbleSort algorithm is the same with the previous complete version, except that we have another Boolean variable called needNextPass. This needNextPass was preset to false every time we enter a new phase. Until one point, at a certain pass, we do not swap anything. At that time, we set this needNext to be true. That means the reason why this can be true is because if you sorted the whole array and there's no swapping happening, that means already been sorted. So we do not need any new pass. So in that case, needNextPass would have the preset false value. So this becomes false, and then the loop started, and the array already been sorted. So we get out of the loop. That improves some time. Time complexity. For the basic version, we will have some formula like this. It's the order of n squared. And this is the time complexity for the BubbleSort. And again, this is a quadratic algorithm, so the time complexity is big. And when the number get big, this is not very efficient. Now, let's look at the demo program for BubbleSort. Before we do that, we need to remember that BubbleSort's core is a successive comparison and swap. And every time we improve the number of the sorted element from 1 to length minus 1. And that's the way we do it. So remember the keyword, successive comparison and swap. Let's look at the program. Right here, let's look at the demo program for BubbleSort. The BubbleSort method has already been shown in the slide. It takes in an array, the name is list, and the outer loop starting k equals 1 to list.length. And k equals 1, as I mentioned before, the k number keeps track of the number of sorted elements that already sync to the sorted list. And next pass is a detector. When the whole phase do not have any swap at all, then we don't need to swap anymore. The inner loop, we start to swap one by one until those sorted elements, those will not be sorted anymore. A sample array is right here, and it takes the BubbleSort. Let's look at the result. I click the package, and let's click and run. As you can see right here, the array had already been sorted. Please download this file and take a look on yourself and try it out. Thank you.